The reason is that this sample had a 2 dilution factor. This required 50 microliters of diluent and 50 microliters of sample. The 50 microliter volume is above the minimum transfer volume that was set at 40 microliters. Thus, the dilution is made in the final well, not in a pre-dilution well. Scroll the steps column to step 226. 50 microliters of the sample from SB1 is transferred to LB6, making the twofold dilution. The formatter does not mix this well since a transfer is not made. LB6 is the destination well. Notice step 233. For this sample block, 40 microliters was aspirated from the vial from SC1. This was dispensed at MA1 and mixed 6 times. Then, step 236. Transferred the final volume of 100 microliters from the pre-dilution plate MA1 to the destination plate LB7. Going back to the steps column, notice that transactions are divided into blocks by a comment line that is shown in red. Should a recoverable error occur within a block, that block of action will be aborted. It will be marked in red for correction under operator supervision at the end of the run. The program will then go on to the next block. This allows the formatter to run continuously unattended. There are some errors that the formatter cannot recover without operator's attention. This will be covered later. Looking at step 30, the diluent has been dispensed to all of the wells requiring pre-dilution. The formatter handles the blanks next. Notice the replication of blank 1, the control blank. File QA4 is opened once in step 32. Multiple aspirate and dispense motions are made, and the vial is returned to QA4 in step 59. There are 9 dispenses of 100 microliters made from the vial at QA4. This brings up the point for those samples that have replicates. The one designated source must have sufficient volume for all replicates. On standards and QC samples, this may not be a problem. However, the diluent and possibly the blanks, it may be. The reservoirs provide access to a higher volume than the cryovials. Each reservoir has a disposable liner. However, the volume of the reservoir may present a problem due to the cost of blank plasma. Reservoir RA1 can be fitted with a removable plug. This plug will hold 4 2 ml vials, providing a capacity of 8 ml. By right-clicking the reservoir location, it will convert that reservoir to the 4-vial format. The vials must be opened manually. The formatter will access the first vial until it receives an insufficient volume signal. It will then automatically seek volume from the next vial. Insufficient volume on the last vial is a fatal error requiring operator attention. Right-clicking the RA1 symbol will reset it to the first vial. Following the distribution of the blanks, the formatter distributes the QC samples as shown in step 61. Notice the division by block that is created by the comment line. Should a recoverable error occur within a block, only that block is aborted and the program proceeds. A typical recoverable error is a meniscus readout failure. The meniscus detector is a secondary check on the volume that was aspirated. The accuracy of pipetting is determined by the pipetter, not the meniscus detector. The meniscus detector simply looks at the meniscus in the tip. Is the volume visually correct? Was the tip occluded by a clot that prohibited aspiration of the correct volume? It is not a precise volume check. The parameters allow setting a minimum acceptable meniscus error. There is no maximum error. If the meniscus reads an overvalue, it has to be a meniscus readout error, not a pipetting error. The meniscus detector is simply looking for insufficient volume on a pipetter aspiration. The minimum acceptable volume is set empirically. The 15% is a starting point. It is desired to keep it as low as feasible without excessive misreads. This can be determined by the reruns at the end of the run report. If the meniscus failures are false, then this percentage may be increased. Should a meniscus failure occur, the formatter will automatically look at the same tip a second time. If that also produces an error, the pipetting template in use defines the error recovery method. The sample is put back or discarded, and a new tip is selected for a retry. If the second tip fails, that sample block is aborted. It is marked in red in the end of run report. The formatter moves on to the next block. Returning to the program steps, the next sequence of samples are the standards. Notice the same block format of replicates. Step 219 begins processing of unknowns. Notice the location of each sample tube is defined. For example, SA1 and its corresponding destination LB5. This program is running by position. The operator must place each sample vial in its defined position. As you scroll through the program steps, you will see the same format of operation and how it relates back to the work list you created. Move to step 757. Notice this dispense has been made to the last well H12 in the destination plate on station L. Step 764 of the next sample has moved to JA1, which is the first well of the second destination plate on station J. Move to step 902. This block is aspirating the last vial from SL8 of the first rack. After step 906, the program will stop and request a change to the second S rack. Note that the next block, step 909, calls for a vial from S plus A1. All of the description so far has been for running by position. Next, we'll review running by barcodes. From import list, import the same incoming file, limbs extended worklist sample.csv. As before, the first screen verifies the deck layout to be used. Select the correct layout and click Next. Since you are importing the same worklist format, you may choose the previous worklist setup, then convert to steps. In this case, we're using exactly the same data. However, the worklist setup is not concerned about specific data for each sample. The worklist setup is concerned only about the worklist format. Thus, the worklist setup is transferable. Instead of running by position, click Run by Barcodes. When running by barcodes, the vials may be placed in the racks in random order. The hand will retrieve the vial, read the barcode, and use the barcode data to cross-reference the rest of the sample information from the LIMS worklist. However, you must highlight the vials that are to be processed. Depending on how you laid out the worklist, they may be highlighted automatically. In this example, they are, since on the worklist we specified that standard 1 through standard 11 would be in QA1 through SB3, the QCs in QC 1 through 3, and the blanks in QD1. When running by position, you are obligated to put each vial in its specific position. When running by barcode, you simply have to have the path highlighted to show which one is next in line, starting from QA1. On this sample program, there was no identifying barcode for standard, QC, or blank. Thus, they must be processed by position. There were barcodes shown for the unknowns. Scroll the step screen to step 219, the first unknown on the listing. Note the barcode is shown on the comment line along with the sample ID. Note also that there is no location for Get Tube on step 221. It is shown as TBD, to be determined. The destination data is defined since that is part of the LIMS data. When the hand picks up the vial and the barcode is read, then the vial rack location is inserted in place of TBD.